4.4 and 4.5, factoring and solving quadratic equations. Look at number 1. When we first see this problem right here, we have to determine which type of problem it is. And if you can see what kind it is, that's great. If not, we go to the flowchart. We always start by asking ourselves if there's a GCF. Is there a greatest common factor? No. How many terms? There were 3. Is it a perfect square? It actually is, but it's kind of hard to tell. So you might even go to this question. If you just skip to say if A is equal to 1, we can treat this as an easy trinomial. All right, this is an easy trinomial, and an easy trinomial is where you look for two numbers that multiply to the C term and add up to the B term. So here's my C term, 1. All I have is 1 times 1. Those are my only possibilities. So I need two numbers that multiply to 1 and add up to 2. That's actually kind of easy because there aren't very many choices. We're going to factor this into two binomials, in and in. And my only two choices are plus 1 and plus 1. So that's factored, n plus 1 times n plus 1. But we can actually write that as a square. This is a perfect square. So we might write it like that to save some space. Problem number 3. Again, you look at the thing and you try to classify it. If you don't know which one it is, you look at the flow chart, and the first question you always ask yourself, is there a GCF? In this case, there is. Both terms have an m, so I'm going to write down that common factor of m, and then we look at what's left. I don't normally like to write this down, but what you're doing is basically dividing. You're taking those two existing terms and dividing by m. One of the m's cancels, leaves me an m. And this m cancels and leaves me a 4. There we go. That's factored. When they say factor, remember, factor means write it as a multiplication. We've got the factor m times the factor m plus 4. Next one. I look for a GCF. No. How many terms? 3. It turns out this is another easy trinomial. A equals 1, meaning this coefficient in the front is 1. So an easy trinomial, we look for k and k here. But we look at that number 18, and we try to find all the ways to multiply to 18. I always start at 1, then go to 2, then go to 3. I try to go in order so I don't miss any. And those are all of the ways that we can multiply and get 18. So what we need to do is think about how we can put a negative in there. There definitely has to be a negative. Multiply to get negative 18. But then they're going to add up to be negative 7. So if you think about it for a second, it looks like if you make the 2 positive and the 9 negative, that's going to do the trick, because those two numbers multiply to negative 18 and add up to negative 7. So I'm just going to put k plus 2 and k minus 9. That is factored. Notice if you switch them around and say k minus 9 times k plus 2, that would still work. It's still going to be the correct two factors. Problem number 7. We look for a GCF. Is there something in common? So look closer. I can't divide them all by 3. I can't divide them all by an x. So no, there is no GCF. How many terms? 3. We can skip this for now and go straight to this question. Is a equal to 1? Well, no, a is equal to 3 in this case. So this is a hard trinomial. So hard trinomial works a lot like an easy trinomial. There's just one little difference. So we're going to factor this, and it starts off kind of the same way. Notice you have to have that 3 there, though. Treat it kind of like an easy trinomial. We need to find numbers that multiply to 32. It's really negative 32, but we can deal with the negative later. 1 times 32, 2 times 16. 3 doesn't go into 32. 4 times 8. 5 doesn't go in. 6 doesn't go in. 7 doesn't go in. I've already done 8. That's it. Those are the only ways to multiply and get 32. Now keep in mind you have to multiply to negative 32, which tells you that there's going to be a negative in your numbers somehow. So let's think about this. The main difference between a hard trinomial and an easy trinomial is these numbers aren't going to add up to 4. Okay? You may look at these two numbers and say, well, hey, those two numbers, you could say 8 minus 4 is 4, and that's true. But the thing is, you got to think about how this works. This is kind of like a FOIL problem. If you go back into number 5 and you distribute the k and you distribute the 2, you're going to get that original problem back. It's like we're unfoiling the problem. So if you think about it that way, this 3x is going to get distributed here and here. And so whatever number goes here is getting multiplied by 3, which means that one of your numbers is getting multiplied by 3. And so that makes it a little bit trickier. So I would probably try to just play around with the numbers. Is this one multiplied by 3? You can do 3 times 1 is 3, plus 32 is 35. If you subtract them, you're going to get, what, 29? So that's not going to work. If you multiply this one by 3, that's going to be 96 plus 1 is 9. That's way too big. So this one times 3, that's going to be 6 plus 16 is 22. Remember, I need to get 4. If you subtract 16 minus 6 is 10. That's not going to work. 16 times 3, that's going to be way too big. 4 times 3 is 12 minus 8. That's going to work. We can do 12 minus 8 and get this 4 that we need. So that kind of tells you that you're going to need a minus 8. And so we look at these numbers. I need to multiply these two numbers and get negative 32. 4 times negative 8. That'll do it. But I also have to multiply the 4 times this 3. And how it works is we know that the 4 has to go right there because that's the position that gets multiplied by this 3. And this minus 8, we can just put minus 8 right there. And there we go. Now we are factored. If you need to check, you can always FOIL that back out. Multiply 3x times x, 3x times 4, negative 8x, or negative 8 times x, and negative 8 times 4. That's going to end up producing this. That was a hard trinomial. Number 9 is the first problem where we have to solve. So in the first couple of problems, we were just factoring, and it doesn't seem like we're really doing anything useful. But what we're trying to do when we factor is try to get to where we can solve. And in order to solve, I'm going to use something called the zero product property. We've got this equals 0. We've got two things multiplied together to get 0. And so how it works is we would know that either this thing or this thing would equal 0. In order to produce 0, either one of those two things is going to have to equal 0. So the way I look at it is this. Think about this as a 0. What number makes this 0? Well, it's got to be 4. You can do the algebra and set that equal to 0 and add 4 over, but I don't think you need to. I'd rather do it in my head. When I look at this number, what number is going to make this equal 0? Well, that's negative 5. And those are my solutions, right? Remember, a solution is the number that makes a true statement. So if you plugged in 4, you're going to get 0. If you plugged in negative 5, you're going to get 0. Now we need to put it all together for number 11. Number 11 we're trying to solve, so we're trying to find the numbers that make 0, but we're going to have to factor in order to do that. So factoring, remember, you've got to be able to classify what type of problem it is, and that's where we're going to the flowchart. We always ask ourselves if there's a GCF first. Is there anything in common? Nope, because this one doesn't have an x. None of them are divisible by the same number. There's no GCF. How many terms? 3. We can skip this for now and go straight to this question. Is a equal 1? Yes, a equals 1. That's this number right here in front of x squared. A equals 1, which makes this an easy trinomial. Easy trinomial says two numbers will multiply this and add up to this. So we look at 3, and we need two numbers that multiply to 3 and add up to negative 2. So if it's multiplying to negative 3, we know one of those two numbers is negative. So in order to make them add up to negative 2, it would be the negative 3, positive 1, and negative 3. So we always kind of give it a framework that looks like this. But then we plug in our numbers. You've got a positive 1 and a minus 3. Now that is factored. But we haven't solved yet because we haven't found the numbers that make it equal 0. So that's where I use my zero product property, and I say, what number makes this factor equal 0? You can usually do it in your head. That's -1. What number makes this factor equal 0? That's +3. Those are my answers. Next problem you might recognize is another easy trinomial. It looks exactly like problem number 11. It's the same thing. So let's do it the same way. I want numbers that multiply to 8. Yes, I know technically it's -8, but we'll deal with that later. I'm going to have v and v. And I need two numbers that multiply to -8 and add to -2. So that's going to be this, right? +2 and -4. Those two numbers multiply to -8 and add up to -2. That's going to do the trick. So that is factored. But solving, we're going to find the zero product property, or just find the zeros. This one's -2, and this one's +4. 15 looks like a hard trinomial, but don't forget, you always have to ask yourself this question first. Is there a GCF? So if you look back at it, you should notice that all three of these numbers are divisible by 4. So what we're going to do is we're going to factor out a 4. We write down that 4 and see what's left. We take a 4 out, we're going to get x squared. It's like division. We take a 4 out, we're going to get 8x. We take a 4 out, we're going to get 15. Think about it as the reverse of distributive property. So we've got that 4 kind of hanging out in the front, but then inside parentheses here, that is another easy trinomial. So we can just let that 4 chill out right there, but then we look at this easy trinomial. Looks like this. I need two numbers that multiply to 15 and add up to 8. So I look at the numbers that multiply to 15. It's pretty obvious that it's going to be those two numbers that add up to 8. So +3 and +5. Now on my zero product property. Sometimes people will look at this 4, but you don't really have to look at this 4. There's no variable, there's no x, so there's no way to make it equal 0. So I don't even look at that. I just look at the variable expressions. So I look at this one, and I've got a 0 value of -3. And I've got this one is -5. Those are my solutions. If you plug in either one of those numbers, you're going to get 0. Number 17 looks kind of the same thing. It looks like the same type problem, but I don't see a GCF. There's nothing that I can divide all three of those numbers by. So this must be a hard trinomial. Hard trinomial, remember, acts kind of like an easy trinomial, but that 2 in the front makes a huge difference. We're still going to look for numbers that multiply to 20. Those are my only possibilities. Those numbers, notice they don't add up to 3. Even if you stick a negative in there, we're going to have negative for -20. But even if you stick a negative in there, those still don't add up to 3, and they're not going to. And the reason why is because when you distribute, whatever number goes right here is getting multiplied by 2. So you have to multiply one of those numbers by 2, and then they'll add up to 3 or subtract. So, I would recommend you just kind of try it. If you multiply this one by 2, that's going to give me 2 plus 20 or 20 minus 2. That's not going to work. So if I do this, that's way too big. 2 times 20 is 40. That's too big. 2 times 2 is 4. I could do 10 minus 4 is 6. That's not going to work. 2 times 4 is 8. If I go 8 minus 5, that's 3. That's it. That's going to work. So keep in mind, the 4 has to go over here because that's getting multiplied by 2. And then what are we doing? We're subtracting 5. 8 minus 5 is 3. So that means a -5 is right there. That's factored. So there's two different questions in this lesson. Either you're factoring or you're solving. Anytime there's an equal sign we're solving, we're finding the zeros. Most people are pretty good at this one by now. Find this 0, it's -4. It's just whatever number is going to make 0. Most people are not very good at this one yet. Okay, but think about what we're doing algebraically. Algebraically, we're saying, where is this 2v minus 5 going to equal 0? So technically what we're doing is we're going to add 5 and divide by 2. And we get positive 5 over 2. Positive 5 over 2 is your other answer. So most people have a hard time doing that one in their head. But really all you're doing, they always want to take the opposite of this number and say 5. Well, that's part of it. But you always also have to divide by this 2. Positive 5 over 2. Notice we didn't have to do that this time because the number in the front is just 1. It's like we took the opposite of this number divided by 1. You're going to get -4 anyway. Last one, number 19. Number 19 looks confusing. It looks weird. It looks hard. If it looks hard, there's almost always going to be a GCF. But that's the first question you have to ask yourself anyway. Look for a GCF. Sure enough, I see one. I see each of those 3 terms are divisible by x. So I take out an x. It's like division. It's like canceling. I take out an x in the front. And in parentheses, you look for another pattern. They're like, oh, yeah, this looks like that easy trinomial pattern. Okay, easy trinomial pattern. So we've got this x kind of hanging out. But then that easy trinomial pattern is going to go x and x like this. And so the easy trinomial pattern says, let's take that number 5, and we need 2 numbers that multiply to 5 and add up to -6. So notice there's got to be a negative in there. They're multiplying to be positive 5 and adding up to -6. The only way that happens is if they're both negative. So they're both negative, so -1 and -5. That's factored. You can see 3 factors or 3 things being multiplied together. Since there are 3 variable terms, we have to find 3 zeros. So we look at what makes this 0, and don't think too hard, it's just 0. We look at what makes this 0, and that's 1. And what makes this 0 is 5. So we've got 3 answers this time, 0, 1, and 5.